Hey guys, today we're going to talk about being able to dilate on a figure on a coordinate plane. So let's get started. Alright, go ahead and call this dilation, and your essential question is how can I enlarge or reduce a figure? I want you to tell me how do you do that. So what operation are you going to use on the coordinate plane? By definition, a dilation is a transformation, our very last transformation, in which a figure is made bigger or smaller. Okay, when we dilate a figure, we have this point at which the figure is made bigger or smaller. Most of the time in here, it's going to be about the origin, that center of the coordinate plane. Okay, and that scale factor is the ratio of the side lengths of the image that correspond. So correspond, the ratio between those, the original figure and the image. Okay, the scale factor is how we enlarge or reduce a figure on the coordinate plane. So I'm not writing this down. If you are actually listening to this, you can kind of actually answer your essential question already. So let's go ahead and get started with some examples. Example 1, tell whether the blue figure is a dilation of the red figure and explain. Is the blue figure a dilation of the red figure? Remember, dilation means bigger or smaller. And did the blue figure change? The answer is no, because it didn't get any bigger or any smaller. It's the same size. Okay, they're the same shape, same size. Sorry, this is actually a reflection. Okay, I would like to see this written in your notes because I'm kind of checking students who are actually listening to the video right now. So I'm not going to be writing down one or two because I want to make sure that you're listening and not just writing down what's on the screen. All right, number 2. Did number 2, the blue figure, get bigger than the red figure? Yes. Are they both squares? Yes. Okay, so they are the same size, same shape. Sorry, not same size. Scratch that. They are the same shape, different sizes, so this one is a dilation. All right, let's go ahead and get started on example 3. Okay, draw the image of the rectangle WXYZ after a dilation with a scale factor of 0.5. Identify the type of dilation. When it says identify the type of dilation, we're talking about, here's the two different types, big or is it small? So first we're going to go ahead and get the ordered pairs so that we can dilate it by 0.5. So we're going to make it half the size because remember 0.5 also means half. We're going to make it half the size. So X is 1, 2, left, 2, up, 1, 2, 3, 4, up 4. Y is 1, 2, right 2, up 4. W should have gone before X. W is 1, 2, left 2, down 1, 2, 3. Uh-oh. And here's a big mistake I see happen a lot of times. You guys do this mistake right here that I just did. Okay. Z is 1, 2, and down 1, 2, 3. I see this mistake so many times. What did I do wrong here? Our coordinates are not going by 1s, they're going by 2s. So I should have been going by 2s and not by 1s. All right, let's go ahead and try this again, and let's do this the right way the first time. I see this mistake happen all the time. Okay, let's try this again. W goes 2, 4, left 4, because we're going by 2s, down 2, 4, 6, down 6. X goes 2, 4, left 4, up 2, 4, 6, 8. Up 8. Y 2, 4, right 4, up 8 because it's the same distance as x, and z goes 2, 4, right, 4, down, 2, 4, 6, down, 6, down, 6. There we go. Now we're ready to reduce the image by half. So what we're going to do each time, and I'm going to make this color green, okay? To get the new image of w, we're going to multiply by 0.5. What's half of negative 4? Negative 2. What's half of negative 6? Negative 3. What's half of negative 4? Negative 2. What's half of positive 8? 4. What's half of positive 4? 2. What's half of positive 8? 4. Oh, z. Image. Okay. What's half of positive 4? 2. What's half of negative 6? Negative 3. And now we're ready to reduce this. We're going to draw it now because it does say draw the image with a scale factor and then identify if it's got bigger or smaller. Okay, so negative 2, negative 3. Negative 2, negative 2, negative 3. Negative 2, 2, 4. Positive 2, positive 4. Positive 2, negative 3. So this is W image, X image, Y image, and Z image. All right, so did this get bigger or smaller? Got smaller, so it's a reduction is what we call that one, a reduction. All right, let's go to example 4. All right, are the vertices of the trapezoid A, B, and C, A, B, C, D, dilate the trapezoid with respect to the origin using the scale factor of 2. Okay, so we have 2 steps that we are going to end up doing here. All right, let's go ahead and get started with step 1. And that is going to be, first we have to draw our trapezoid. So negative 2, gotta draw my coordinate grid. All right, I'm going by ones in my coordinate grid. So A's image is negative 2, 1, 2, negative 1, A. B, negative 1, up 1, B. C, 0, 1, and D, 0, negative 1. All right, we drew our trapezoid. All right, dilate the trapezoid with respect to the origin using the scale factor of 2. So let's go ahead and draw our image. So we have A image multiply by 2 times 2. Negative 2 times 2 is negative 4 times 2. Negative 1 times 2 is negative 2. B. Negative 1 times 2 is negative 2. 1 times 2 is 2. C's image. 0 times 2, 2. 1 times 2, 2. Oh, what am I saying? 0 times 2 is 0. Rewind. 0 times 2, 0. D. 0 times 2, 0. Negative 1 times 2, negative 2. All right, so we dilated, then translated 6 units up and, 6 units right and 2 units up. All right, so what we just did is we made this shape bigger, made it bigger. Let me go ahead and draw that in there. I'm going to pause the video and draw it in there. All right, so we made the picture bigger, and now we're going to slide it 6 units right and 2 units up. So let me go ahead and let's write out the new coordinates. We're going to put this one in blue. Okay, so a second image plus 6, 6 units right, positive 2, and then 2 units up, plus 2, 0. Okay, B, second image, plus 6, not the same sign, find the difference, keep the positive because 6 is further from 0, so plus 6 plus 2. C, second image, plus 6 plus 2 plus 6 plus 2. D, second image, 6, comma, 0. All right, I'm going to pause my video. I'm going to graph this one. All right, I graphed mine and it went slightly off, so here, let me highlight it. All right, the green shape on my picture and the blue shape are the same size, same shape. Okay, yours should look exactly the same, just slid over. Alrighty, and we did it. What are the coordinates of the new image? Here's the coordinates of the new image, and now we don't have to do it. Alright, let's go on to example 5. Alright, the red figure is similar to the blue figure. Okay, same shape, different sizes. Okay, describe the sequence of transformations in which the blue figure is an image of the red figure. First of all, there's going to have to be a dilation because it gets smaller. So a dilation, and then the picture looks like it turns a couple of times, or it could almost be reflected over a line like that. So it can be rotated or reflected. And we will get more into this tomorrow, where we talk about a series of transformations. But today we're just talking about dilation. By the way, the order of this can switch and it still does the same thing. All right, let's go ahead and look at the on your owns. Go ahead and pause your video and try these 3 on your owns. Okay. Thank you for pausing your video, and here's what you should have gotten. Yes, I should see number 2 written down on a coordinate grid, and it got bigger, so it's an enlargement. Okay. So number 3, you should have told me that first of all it turned and it shrunk. Turned and shrunk. All right, go ahead and answer that essential question, and your checkpoint's ready to go. I hope you guys are having a good morning. I hope you had a great weekend. Let me know if there's anything I can help you with.